Welcome back to Gophercises. In this video, what we're going to do is look at some HackerRank problems. So HackerRank is this other website. There's a bunch of them like it, but basically it's a website that has programming problems on it that you can go, try to solve in different ways. There's a lot of data structure and algorithm specific problems. People will often use the site to practice for interviews and to sort of get interview prep for that type of, brain teaser type questions and things like that. But really, there are a lot of problems on here that are just a good way of getting familiar with the language and just, getting familiar with writing some code. So I'm going to go ahead and show you how to solve two problems on it with the goal that, when you create or when you finish Gophercises, or maybe you're just looking for other things to do in your spare time, you can find problems on here, and because it accepts Go code, you could go practice writing some Go. Now, I will mention that I'm pretty sure the last I checked, it only accepts Go 1.6, and the current version of Go is like 1.9. So, it's not going to have everything you might come to expect in the most recent version of Go. And the other thing is it only lets you use things in the standard library. So you can't pull packages from golang.org/x. You can't pull packages from other third parties. So none of that's going to work here, which can make some problems a real pain. And it's just the way it is, I guess. They might eventually change that, who knows? But for the time being, you kind of have to deal with it. The two problems we're going to look at are called Camelcase and Cipher. So the first one, Camelcase, the main idea here is that you're going to be given a Camelcase string. And if you haven't ever seen a Camelcase string or you don't know what it is, you can read the description here. It'll cover what all that is, and you can go from there to figure out what you're supposed to be doing. And then the second one is this Cipher. And it's going to be giving you a string, and then it's going to be giving you an integer, which is used to cipher that string. And the way this cipher works is basically, if I read it correctly, you basically just add in it, you take the ASCII value of each different letter, you add this integer to it, and if it loops beyond the range of what the character's ASCII value should be, so for A to Z, there's going to be some set of ASCII values. If it goes beyond those, you need to use the remainder operation in Go to figure out, how does it loop around. So for example, if you add 1 to a Z, it should become an A. And likewise, if you add 2 to a Z, it should become a B. And you can see that here in the sample input. The Z at the very end, when you add 2 to it, it becomes a B. So that's probably the trickiest part of this if you're not familiar with manipulating ASCII characters, especially using their integer values. And that's something to keep in mind. The one more thing that I do want to mention before I let you go off and try to solve this problem. When you come down here, you are going to want to go to Go. And the other thing to remember is that you're reading input from standard in and you're outputting to standard out. So this input here that you're going to read, it's going to be things that you would type into the terminal whenever you run your program. So if you do go run, main.go for your program or whatever you name it, you're going to type these things in. You can pipe input to them, which I will show you in the videos, which will help speed things up, but your program is still reading from standard in and it's printing out to standard out. This is something that sometimes can be annoying, especially when the input's in a weird format and you have to parse it in a weird way. But for both of these problems, you should be able to use the Fumpt package, has this scanf, if I can find the definition of it. Here's scanf. It has the scanf, which is a way to read input from standard in. And there's lots of examples online of how to use this. So if you get confused or you just want to sort of see how it works, that'll work. But basically that's where I'd probably start, is just using that to read in different input. All right, I think that's everything I need to cover just to sort of get you started. There aren't really any bonus exercise or bonus things for this, aside from, if you want, you can go solve other problems on HackerRank. And that's, as I said, that's part of the purpose of this, is that you can go solve some more on your own, especially if you've completed Gophercises and want other things to do. Okay, we're going to get started with the Camelcase exercise. We're going to go here. You should read the exercise if you haven't already. I definitely suggest reading over the entire thing. But the basic rundown here is that you're going to be given a single string. It's going to be a Camelcase word. It's going to start with a lowercase letter. It's going to have at least one letter and up to 10 to the 5th letters. And in each string that we're given, there's going to be new words started by a capital letter. So if you look here, the new words are changes in the and editor. And every time there's a new word, it starts with an uppercase letter. So our goal is going to be looking at that string, figure out how many words are there. So the first thing I like to do is make a directory for my code. I like to have a separate directory for every single problem on HackerRank because every problem I want to write is going to be in the package main, and it's just easier to separate them all if they're on their own package. You can also toss input files and things like that inside the directory, which really makes things easier. So I'm making the camel directory. I'm going to cd into it, and I'm going to atom main.go. Should bring me up. So I'm just going to go ahead and just save this for the time being. I'm going to come back to it in a moment. The other thing I want is atom camel.in. So this is going to be my input file. Now I told you that we're going to be reading from standard in, and we're still going to do that, but I'm going to show you how to pipe the input from this file to standard in so that you can write your program for HackerRank so that it'll still work there. But when you're running locally, you don't have to type everything in every single time. You can pipe the input in so you can keep testing with the same input. And this is especially handy if you have, say, a couple different use cases you want to test. You can create 3 or 4 different input files, and you can run each one individually and see if the outputs are what you expect. So to do this, we're going to var input string, and we're going to read this input. So we're going to use scanf, and we're going to say %s, which means I want the string, and I'm going to put the new line character at the end saying that I'm expecting there to be a new line. And then I'm going to pass in a reference to this input string so that it can assign the data that it reads into that variable. And then finally, I'm going to print out input is, and then print out the input, just to verify this is all. So from here, we can go run main.go. And if I type in a new word, you're getting that input. But as I said, I don't have to type it in every time. So I'm going to use this less than character. Then it's camel.in. And this will take the input from the camel.in, or the text from the camel.in file, and it's going to pipe it into my program as if it was coming from standard. So when I press enter, you'll see here that I don't have to type anything. My program sends the input from like it's standard in, and then it goes ahead and prints it out. I believe this works in Windows. I know it works in most Unix environments, but if you are in Windows and it's not working, just ping me. I'll try to help you figure out the right way to do it in your case, but I'm pretty sure it's the same. You can also do this for output. If you put the greater than, this means to pipe the output from standard out into, say, camel.out. And then you'll see here, cat is just going to print out a file, but I can print out camel.out. And it's showing you here that this is the text that was saved in this camel.out file. So this is also handy whenever you're running many different test cases, or say you do like Google Code Jam, and you want to, when you do Google Code Jam, it's similar to HackerRank, but basically every problem you don't actually submit your source code, you just take in an input file and you submit to them an output file. Well, I think you do submit your source code, but they don't run. So you submit an output file to them. And when you're doing that, you might want to run something like go run main.go, where you pipe in some input and then you pipe it to an output file and then you just upload that out. So really handy to know if you're doing this. Okay, so going back to our code, we're going to get rid of that. The next thing we want to do is figure out how many words are in there. Well, we know that since our strings are at least 1 character and the first letter is always lowercase, we're going to know that there's always at least 1 word in this. So we can actually do answer is going to just start off as. So from there, how we figure out if there's more words is we look through the rest of the string and we look for capital letters. Every time there's a capital letter, it means we've started a new word. We don't even have to split it into words like they do here. Since all we're doing is counting how many words there are, we really just have to go through the string and look for capital letters. Well, to do this, we're going to use a for loop, and we're going to say for underscore character. Let's use R, actually. I'm going to use ch for character. For the character in the range of input, and then we would do print this out. And we're just going to see what happens. That's not. This is what I want. All right, so you see here we're getting a lot of numbers printed out, and it's kind of weird as to what's going on. So the other thing you might be wondering is, how are we ranging over a string? That's not a slice, it's not a map. That doesn't really make sense. Well, behind the scenes, strings are really just a byte slice. So, if you wanted, you could actually say like b : equals and convert this to a byte slice from the input. And then we could do something like that. Print it out, and you'll see here that this is just a slice of all of these numbers. And you'll notice that all of these numbers are actually the same numbers that printed out here, except for the one at the end, which is our. So I could probably comment that out so it's not confusing you. But yeah, I'm going to leave it because it's going to make. But yeah, so we've got all the same numbers there. Well, what's happening is whenever you have the byte slice and you print it out, it's just printing out the byte that's at each individual index. Whenever you do a for loop over a string, it's something similar, but it's not quite the same. So what's really happening whenever you, sorry, I'm going to delete that code since we don't need it anymore. Whenever you do this for loop over a string, Go will actually turn, or every one of these CHs you get back will actually be a rune that is UTF, based on UTF-8 encoding. It'll go through the string and figure out which one is a rune. So a rune is a little bit different than a byte in that not all UTF-8 characters are a single byte. Sometimes they can be composed of a little bit more than that, like emoji and things like that might be composed of more things. So what this is doing is it's actually going through that entire input string, and it's figuring out, all right, which one of these are basically runes or characters in the UTF-8 standard, and it's going to assign them to the CH. So what that means is if we were to actually look at this index, this I part here, and we do index I rune ch. So we print this out here. We're getting index 0, 1, 2, 3. So you're seeing here the index is increasing by 1 every time. But if we come here to the Go blog, you'll see that they actually show you some examples where that isn't the case. So we could actually copy this part here, and let's just go ahead, comment this, print this, and we'll say, we'll do this, and then we're going to run this. Well, you'll see here what's happening is it's getting every individual, piece here, like each individual character is what I'll call it. Each individual rune is getting pulled out, but whenever you look here at the indexes, we're at position 0, 3, and then 6. So what's happening is that some of these are composed of more than one byte. And as a result, the index is increasing by a different amount. It's not increasing by 1, it's increasing by, however many spots there were until it got to the next UTF-8 character or rune. So that's something to keep in mind, is that when you're using this for range in Go, it's actually really handy because it does this type of encoding for, decoding type thing for you. It goes through and figures out what each character is so you can work from it. In our case, it actually doesn't matter too much because it says here in the problem that we're only going to get characters that are English letters, which means A through Z, and all of those fall within a single byte. So, it's not a big deal for this problem, but it's something to keep in mind when you're doing real world problems where the input isn't guaranteed to be of some certain format and users could sort of give you almost anything. And Go really makes it easier to deal with that, especially compared to some other languages that didn't really have to think about this as much because at the time things like emoji and stuff like that just weren't as popular. And let me actually see here if I can add something like this, save it, and let's go see what happens here. You'll see here, yeah, this is a good example, that we do have index 22. Yeah, at index 22, we've got this rune that's, it's definitely a much bigger number than all these other numbers. And it's increased, whenever we have it there, it increases up to index 26 before it goes to the next character. And that's right here, we've got this, flexing arm emoji. So that's the type of thing that, this is really going to help you handle correctly in your code is weird characters like that you might not be thinking about. So I'm going to get rid of that. I want this to be the same input so we can test. But that should give you an idea of what we're doing here. Now, we're not going to be using this index. Instead, we're just going to be using the characters that we get for each individual index. And what we're doing here is we're going to look for capital letters. Well, there's a couple different ways you can do this. One is you could say something like min is going to be equal to A. And I'm using single quotes here so that I get, so I'm not getting, I can just show you. It's printf. %t will give you the type of a, whatever you're trying to work with. So we can actually do %t, and we'll do %t again. And I'm going to put the character here at the end. So if I print this, you'll see that these are all int32s. So, these two types are, both going to be, I believe of the rune type is roughly what the equivalent to. So, that's what's going on here. But if I were to instead put quotes, it's going to be string, which is not what we want. We actually want just the individual character here, so that's why we're using these single quotes. And what you could do then is you could say min, comma, max, I didn't mean mix, I want max, are equal to A and Z. And then what you could do is you could say if this character is greater than or equal to min, and the character is less than or equal to max. So if it falls within the range of capital A to capital Z, then you could say, all right, then I know this is a capital letter. It is a capital letter. And we could say answer plus plus, and then we can just run our program. And you'll see here when we run it, we now get the output 5. It's saying there's five different words in our string because it found 4 capital letters, and it starts off with the answer being at 1. So that's one way to do it. But to do this, you have to sort of think about characters and thinking about different things like this. So maybe you don't want to do that, and instead you want to sort of rely on some of the tools that are already in Go. So one of the things you can also do is you can easily convert this character to a string. So you can do that, and it'll actually print out that character every single time. So you see save changes in the editor. That's all getting printed out there, just one character per line, but each character is a string in this case. So what you could do here is if strings.toUpper, which will convert a string to uppercase. So what we could say is str is equal to string of the character. So if strings to upper of string equals the string. So what I'm saying is if I convert the string into uppercase and it's still equal to itself, well, that means the string was already in uppercase. So that's a real handy way of saying, just verifying that we had an uppercase letter, and we can say answer plus plus here. And what I like about this approach is that it's a little bit clearer as to what you're checking. When you get capital letters and you're checking these ranges and stuff like that, it works, but it's not always completely clear what you meant or what was going on there. So this is something that I think is sometimes a little bit clear, especially to somebody who's new to, thinking about underlying data types. This can be especially true if maybe you're coming from like Python or Ruby or some other language where you don't think as much about underlying data types because they're dynamic languages and you don't have to do much with them. You just sort of write your code. So, it's something just to keep in mind here. Sorry. I'm gonna try to resume. There's a dog outside barking and my dog's getting a little worked up, so hopefully he won't make too much noise here. I think at this point, we're actually done with our code. I think this is all we needed, and you'll see here that it's not an incredibly large program. It's 20 lines of code, but I think that does what we needed. So I'm gonna go ahead and copy all this. I'm going to go back here, and we're gonna paste it all in here. I will mention you can code here, and you can see you can run it, and it'll go ahead and process your code and output stuff, and it'll tell you if it was right or wrong based on the sample use case. You should definitely submit your code when you're done instead of just running, because the sample use cases they give you, there's going to be more test cases once you submit it. And then the other thing I'll say is I don't often edit here. I pull all the things and run them on my local editor or my local computer because I have a lot more code completion and things like that that are just much easier to work with. Hey, bud. But it's something that if you want to, you could code right here, especially if maybe you're not on your computer and you just want to work from. So I'm going to go ahead and submit my code, and we're going to see what happens. And you'll see here that, as I said, there's a lot more test cases. So it's running it against all those test cases, and if one fails, it'll tell you. In this case, it looks like we got it correct. So it says, congrats, you solved the challenge. We get some points, and that's it for this challenge. All right, in the next video, we'll look at that Caesar cipher, and then from there, you can go off and try to solve these problems on your own. The last part of this exercise is going to be solving the Caesar cipher problem. So the basic idea of how this problem is going to work is we're going to have 3 lines of input. The first line is going to be the length of the string we're trying to cipher. The second line is the string we want to cipher, and it will be of whatever length the first line said it was. But we won't actually need to look at the first line. Like, we're going to record it in our input, but I'm just going to tell you up front that we won't actually need it. And then the third line is going to be the key or the encryption key that we're using to cipher this. And if you read the problem statement, you'll see roughly how this works. Basically, every lowercase letter gets added some amount. Say you had the alphabet in all lowercase. You would basically find the index of whatever letter you want, and you'd rotate whatever the key is. And the key can be anything from 0 to 100. So the only really unique cases are uppercase letters remain uppercase, lowercase letters remain lowercase, and whenever you get to the end of the alphabet, so the Z here is an example of this, there's no more letters to rotate to, so you reset back to the start of the alphabet and you keep on moving as if you'd just been from there at the get-go. So there's a couple different ways to solve this. We're going to look at roughly two. One is going to be a slightly more generic one that'll give you an idea of how to do it if you don't really understand ASCII values. And then the other is going to look at ASCII values for characters, specifically alphabetic characters, because those tend to be ones that you won't need to know a lot about. You won't need to use them a ton, but they do tend to pop up in some specific cases. And this is especially true if you're looking at HackerRank type problems. I don't like to spend a ton of time on them because realistically I see them a lot more in these algorithmic type problem competitions than you see them in the real world, but they do pop up from time to time. So I already have some code here. This code will read in the input and print it out. So let's just go ahead and see. I've already got this Caesar.in. If you want to see it, this is all inside my HR1. I have the Caesar folder. I've just got main.go and Caesar.in. And, whenever I run this, it'll read in the input and print it out. So I just have this printout part just to verify I'm reading input correctly. We aren't going to use it long term, so I'm just going to go ahead and just delete it. Well, I'll keep it for the time being, but I'm going to comment it out. Okay. So I kind of explained the algorithm we're going to be using already. Basically, the overall idea is that, say we have some alphabet, and this is... I'm just going to copy this. I have it written in my notes, and I don't want to have to type that all up. We've got some alphabet. Basically, we're going to go through every single letter in the input, and we're pretending at this point that there's no special characters, no uppercase letters. We'll handle those shortly, but we're going to pretend for now that there aren't any. We're going to go through this alphabet, and we're going to find that character, and then we're going to take wherever it is in the alphabet, and we're going to rotate it by the delta. And on top of that, we need to remember that, say we start at Z, if we add 1 to it, we're going to have to reset back to 0, and you keep going through there. So that's generally, that's the general idea of what we're going to be doing. The more general way to put this is, and by more general in this sense, I mean, we could also write a solution to this where this alphabet key can change. For instance, we could make this alphabet key... let's comment out the first one. We can make this A, B, C, D, F. I'm skipping E here, that's fine. But then if we wanted to say convert input equals bad and delta equals 3, we could rotate this and we would end up getting something like FDB, where B plus 3 is F, A plus 3 is D, and this D plus 3 is going to be, it's going to get to the F, it's going to wrap around, and it's eventually going to go to the B here. So, the D is plus 1, 2, 3 gets us there. So what I'm trying to say is that more generally speaking, when we write the code this way, where we're using some alphabet slice and we're just rotating inside of that slice, we can work with all sorts of alphabets. It doesn't have to be the English alphabet. We don't have to rely on specific things with ASCII characters. And that's why we're going to look at this solution first and then go to the one that's, very, very specific. Okay. So that's what we're going to be doing. I need to put a colon here. And we're eventually going to use this alphabet variable. So I'm just going to let it be for the time being. I'll just do this so the compiler stops complaining. And don't do this a lot in production code necessarily. It's not something you want to commit. It's just something I'll put in this so that my code compiles for the video. Okay, so the code. Before I jump into it, there's one more thing I want to mention, and that is you're going to be tempted at times, especially if you're talking with people from other languages, to treat this as a byte slice. And that's not always bad, but that means that if I were to insert a special character in here, like say a smiley face, then your byte slice isn't going to treat it correctly. So this is actually a rune, and whenever you're dealing with runes inside of your code, you need to handle them a little bit different, but Go makes that pretty easy. So we can actually convert strings into byte slices, or we can convert them into rune slices. So we can do something like a rune slice, and the parentheses are converting it. They're not the same as instantiating a slice. So this is roughly the same as saying ABC : equals rune. And going through like this and manually putting every single rune, except this will just go ahead and convert it for us. And I'm going to delete that smiley face. All right, so knowing that we're going to work with runes, that means that our rotate function should take in the rune that we want to rotate. We're going to find it somewhere inside of this rune slice, and then we're going to rotate it by the delta. So that means we can start off by defining our function as func rotate. It'll take in some rune s, a delta, which is an integer, and it'll take in, I'm going to call it a key, which is a rune slice. And then it's going to return this rune. So the rune it's returning is the rotated rune. So the first thing I said we're going to do is find out where this rune that we're looking for, that we're rotating, is inside of the alphabet. So inside of this key. To do that, we're going to say the index is equal to -1. So we have not found out where it is in our key yet. Then we're going to iterate through every rune inside of our key. And we're going to say if the rune at this index is equal to s, then the index is equal to this index, in the actual key, and we're going to break. So we don't need to go through this for loop anymore once we found a match, so we can break at that point. At the end of our for loop, we don't know for sure if we've had a match, so it's a good idea to put something like if IDX is less than 0, so if it's still -1 and we haven't found an index, panic, IDX less than 0, something like that. I'm leaving this error message, or this panic, really generic because it's not something I'm expecting to happen, and this code is not something that I'm planning on using elsewhere. It's just to solve this hacker rank problem, and that's it. Now, if I were putting this in a library or doing other things like that and exporting it to other people to use, then I'd want to do something better than this. I'd want to use some error handling of some sort, do something else. But in this case, we can just let it be. All right, so now that we know where the rune is, we want to add this delta to it, and we know that anytime we get to the end of our rune slice, we need to reset it back to 0. So that's going to look something like for I equal to 0, I is less than delta, I plus plus, and we'll say that index plus plus, if index is greater than or equal to the length of the key, so if we've gotten to the end of that key slice, then index is going to become 0, so we're resetting back to 0. Finally, we want to return the rune inside of our key at this index, and that's how we do the rotation. So let me minimize that. So let's go ahead and see how this works using one of the examples from the examples in the problem statement. So we know that z plus 2 is supposed to give us a lowercase b. So to test that, we can do new rune is equal to rotate. We'll give it a z, we'll give it a delta of 2, and we'll give it the alphabet as our rune slice. Then to test it, we're just going to print it out. We're going to convert it into a string. And that's only because runes are, they're more integer values behind the scenes, and we want to be able to look at the actual string value. We don't want to look at an integer. So we're going to convert this rune to a string, which you can do just by doing string and conversion like this. All right, so if we run this, you'll see that it outputs b. So the z has become a b. We can test another one of these. We can go m plus 2 is supposed to be o. So let's put m in here. Run the code, and we get an O out. So it looks like our code is mostly working as we expected. I say mostly because that wasn't a complete test of all the possible use cases, but it looks like it's pretty good. Okay, so this whole rotate function, it works, but there are ways to improve it. And I'm going to go ahead and talk about the Modulo operator, which will really help us improve this code and make it much simpler. So the first thing is, let me just explain what this modulo is. So in integer math, let's say we had something like 4 divided by 3. Well, we know that this is going to be 1 in integer math. If we were doing decimal math, it would be 1.3333, something like that. But in integer math, you always get integers back. You don't get floating numbers back. So what it actually gives you is the number of times that, the number of whole times that the numerator will go into the denominator. So 4 is our numerator, 3 is our denominator. 4 goes into 3 one time fully. Well, sometimes in programming, especially with integer math, you want to know what's left over. So if we had 4 modulo 3, what this is going to do in Go is it's going to give you the remainder. So that means that it'll give you the number 1 back. Well, it looks like they're the same here, but they're not. So if we did 5 divided by 3, this is going to be equal to 1 still, because 5 still only goes into 3 one whole time. But 5 modulo 3 is equal to 2, because there's 2 left over at that point. What's interesting about this is that any number modulo some number x, the result is always going to be in the range of 0 to x minus 1. So what this means is that we will always get a number somewhere in that range. Well, why this matters, and what does it do to help us? If you're looking at the length of this rune slice here, let's say we're at z, and we're looking at the index, that's index 25. So if we're at index 25 and we add 2 to it, that gives us index 27. Well, we know that that's outside of the range of this alphabet, but if we were to modulo that by the length of this whole slice, which is 26, we'd end up with something like 25 plus 2 modulo 26, which is the length of the alphabet string, and this will give us back a 1. So it's 27 modulo 26, which is 1. Well, if you look up here at this alphabet string, the character or the rune at index 1 is B. That's the character we wanted. So this modulo is really nice because this whole for loop down here, where we're resetting the index to 0 every time that we get to the end, and we have to run that for loop as many times as delta is. If our delta was 100, we'd have to run that for loop 100 times for every single character we're rotating, which it's not so bad that we'd probably waste too much time because it's only 100, code's gonna be pretty quick. But we're still doing 100 loops of that for loop or iterations of that loop that are completely unnecessary. We could just do the modulo operation once and know exactly which character we wanted. So what we end up doing here is we end up saying that index is equal to index plus delta modulo the length of the key. And that replaces this whole section of the for loop. And there's lots of other use cases where the remainder operation is going to be useful. And I should mention that in Go, this percent is the remainder. You'll hear it called the modulo and the remainder and things like that. And I don't know the actual, what the symbol is supposed to be called in Go. I haven't looked actually, but the only real difference between doing modulus and remainder is when you're dealing with negative numbers, there'll be a slight difference. But in this case, we're not dealing with them, and it's a little bit more rare to deal with negative numbers, so I'm not going to go into those right now. While we're here, another thing I do want to mention is that you can clean up some of this code here as well. One way to do this is to use the strings package. So instead of calculating the index ourselves, we could do strings.indexRune. And to use this, it's just a function provided by the strings package. You pass in a string that you want to find a rune in. So string, we'll turn this key into a string. And then the rune we want to find is this S that was passed in. And it does the same thing our for loop does. It goes through the whole thing, looks for the first instance of that, this rune inside of this string. And if it finds it, it returns its index. If it doesn't, it returns a -1. So we can use it exactly the same way we were, and it just cleans up our code a bit. So now that we have a cleaned up rotate function, let's look at how to go back to the original problem that we wanted to solve and to solve it. So first thing we want to do is we want to have some way of determining if the character we're looking at in the input is something we can rotate. Now there's a couple different ways to do that. One is to just see if it's inside of the string, or inside of the alphabet. We could say, all right, go through the whole thing, the same as we did with index rune here. We could just say, tell me if it's in there. If it's greater than -1, then I know it's something I can rotate. That's one way to do it. And I guess we can just start there. That's fine. Let's do actually we're going to say ret is equal to the empty string, and eventually we're going to print out ret. We're going to get rid of those two because we don't need them right now. We're going to say for every single character inside of the input, we want range input. We're going to say if strings.index rune string we want string of alphabet. And this is something where I'm going to go ahead and just change this a bit. I'm going to say alphabet string is going to be equal to this part, and alphabet rune, I'll just say it's alphabet, is rune slice of alphabet string. And this isn't really a huge thing. I'm just doing it so I don't have to continuously convert this back and forth. I'm not even sure at this point if there's not a huge reason to keep both versions, but it's fine. So we're looking for the index of the rune, ch, inside of that alphabet string. So, and if it is greater than or equal to 0, that means that it found a match of some sort. So if this happens, what we're going to say is we're going to say ret is equal to ret plus, we want to rotate. We're going to rotate the character by delta, and alphabet is what we're going to pass in as our key set. And I wrap this whole thing in a conversion into a string just to make sure that when we're adding this rune to this string, that it ends up getting added correctly. I don't know if we need that for sure. I'll check here in a second. Then we're going to add an else statement here that if we aren't rotating it, what we're going to do is we're just going to say ret equals ret plus string ch. And again, I don't think we actually need that, but we're going to go ahead and see. So you can see here that we have OK, FF, and G. So if we come back, that's exactly what we were expecting here. Now, the only thing that isn't working are these capital letters, and that's because, well, first, let me see this real quick. Okay, it's complaining, so you definitely need it. That's fine. So we don't have the capital letters, and that's happening because whenever we look for, say, a capital Q inside of our alphabet string, well, clearly it's not going to find it in there because, there's no capital letters. There's just no capital letters in the string, so it's not going to find them. There are a couple ways to handle this. One is to create two alphabet strings. Maybe one is for uppercase, one's for lowercase letters. Really, how you do it's up to you. I'm going to go ahead and just keep this alphabet string the same. And what I'm going to do is I'm going to just check to see if the character is uppercase. And if it is, I'm going to convert it to a lowercase character and then check to see if it's in that string. I take back what I said. Originally, I was going to just convert the character to lowercase. I could do that. I don't know if it's worth doing. So what I'm going to do is put a switch statement here. And I think this is going to be a little bit easier. We'll say this is alphabet lower. And let's just go ahead and create an alphabet upper. And to do this, I'm going to just convert it to uppercase here in my editor. That way I don't have to do it in code as much. If you wanted, you could just have your code convert the lowercase to the uppercase, and that would be fine, but we're going to just leave it as is for now. And I'm going to get rid of that. We'll eventually deal with it in a second. So what we're going to do here is we're going to say case 1 is going to be strings.index, and in this case, we still want index rune. We're going to say if alphabet lower has the rune we're looking for, then in this case we're going to say ret equals ret plus string, rotate the character, the delta, and then we're going to convert alphabet lower into, I did that wrong, we're going to convert alphabet lower into a rune slice. So that's what that ends up looking like. Assuming I got all the code right. Oh, I want this to be greater than or equal to 0. Okay. So if I find this character, or this rune, inside of the alphabet lower string, and it has an index of greater than or equal to 0, then I'm going to go ahead and say use that string and call this rotate function. Our second use case is going to be the exact same thing as this, so I'm just going to copy it all and paste it here. Except instead of alphabet lower, we're using alphabet upper. So you'll see here that it's basically the same thing, and that's one of the upsides to writing this rotate function like we did, was we can just pass in both of these alphabets and it's completely fine. And if our string, or if our character does not show up in either of those strings, if it's not an uppercase letter or a lowercase letter, we're going to have a default case that just says ret equals ret plus string, and we're just going to keep that character as is. So I think that's everything we need to do right now. I'm pretty sure this code is completely done and it'll work. So let's go ahead and test it out. And let's see if this input is what we have on this page. And whenever I do a find, it's finding it, so it looks like it's matching it correctly. So I'm going to go ahead and copy what we have here, go back and paste it in. You'll see that I'm not importing any packages that are outside the standard library, so this should work fine. I can get rid of that, and we can go ahead and just run this and see what happens. So I'm going to run it once just to make sure it works with the sample case, and it looks to be correct. So we can submit the code and see what happens. All right, so our code works fine. We got all the test cases right. What we're going to look at next is just some of the things you could have done if you were working with specific ASCII values and understood them a little better. So let me get my notes real quick. Okay, so we have a working solution. The next thing I want to do is just sort of talk a little bit about ASCII values and how we can use them to solve this problem without actually dealing with strings, rune slices, and iterating over that slice and trying to figure out where that character is in it. So it's not really clear when you call a function like index rune, but it is worth noting that when you call it, I'm actually passing in this string, and it's going to iterate through that entire string until it finds the rune that we're looking for. So if we passed in a Z, it's going to look at every single letter until it finally finds a Z. Well, this could be a little bit slow, especially if your alphabet gets really big. There's some situations where maybe it doesn't make as much sense, or you're just trying to optimize your speed, as much as possible for whatever reason. So one of the things that's worth noting is that if we take all of this code and comment it out, and we do something like, let's just print out A, B, and then we'll print out Z. So if I run this, you'll see that I get 97, 98, 122. Well, when we're dealing with the letters A, B, C, D, all the way up to Z, they're all sequential. The way they're stored as integer values behind the scenes, the way they're stored as bytes, they're always sequential. So we've got A, B, C is 98, or 97, 98, 99, all the way up to 122. Capital letters are the same, they just start off at a different spot. So if I change these all to capital letters, save my program and run it, you'll see here that we start at 65, 66, and it goes all the way up to 90. So the reason this is useful is that it means that instead of creating this here slice and doing this doing the math based on the length of the slice, we could just rebase our rune based on whether or not it's uppercase or lowercase. We could do the math, and then we could put it back to the original base it was in and return it. And what I mean by this is func rotate upper. This is going to return a rune. So what I mean by this is when we rebase it, well, we know that this uppercase A starts at 65. Well, we know that our original code we wrote, it was much easier when our array index started at 0. So if we wanted to pretend like this was a 0 instead of a 65, the easiest way to do this is to say that temp is equal to int r, which is going to be 65, minus a, which is also going to be 65. So essentially what we're saying is rebase this as if a is 0. So you'll see here that if I print this out, rebased, and temp, it's going to eventually give us a 0. So up here, I'm going to do rotate upper. Let's give it a, well, it's going to be 0 if I pass in A is what I should say. If I pass in other letters, it'll be a little bit different. So we'll do this, and we'll do our delta as 3. And then I'm going to pass in a B as well, just so you can see how they both work. And then this is going to return, I'm just going to return A for now, that's fine. So you see here I've got a rebased of 0 and a rebased of 1. So A gets rebased to 0, B gets rebased to 1, and now these are very similar to when they were in our slice, except we aren't creating that slice. We aren't going to have to look through that slice to find things. So we've got them rebased. The next thing is we want to do that math we were doing. So we can look down here and see the math is just index plus delta percent the length of our slice. Well, we know that there's 26 letters in the alphabet, so we can say that temp equals temp plus delta percent 26. And then, so that's going to give us, whatever the number should be after we've rebased it, but we want to take it back to that original base. So we want to bring it back to, we need to add that 65 that we took off of it in the or at the start, so that it goes back to being a capital letter and not some other random rune. So what we're going to do here is we're going to say return rune temp plus A. And I'm using A here to make it clear that I'm basing this all off capital, like the capital letter A being the lowest letter. You could just write 65, it's less clear in my opinion when you're looking at code like that. So using this character makes it a little bit clearer what you're trying to do. So if I go ahead and I'm going to get rid of this print line and I'm going to print out these strings. And you'll see here that, what is it? I need to put a parenthesis at the end, I think. All right, so if I run this, you'll see that A rotated 3 times gets me a D. B rotated 3 times gets me that E. And those are both correct. Another use case we're looking at is the Z. So we can go ahead and print that out. A Z rotated 3 times gets me C. So Z, the next one's A, B, then C. That's the third one. Okay, so that's working. The problem is this is, it's only rotating uppercase letters. How do we fix this so that it works for upper or lowercase? Well, we'll say rotate any R rune delta int and returns a rune. What we're going to do here is we're going to say if our rune is greater than or equal to A and it's less than or equal to Z. What this means is if you're looking at the integer values, well, A is a 65, Z is, I believe it's a 90, yep. So we're saying if R's integer value is greater than or equal to 65, less than or equal to 90, then we want to call that whatever's in this if statement. So we could say rotate, and I'm going to rename this, rotate with base. So we'll say R base, and let's see if that works. This might need to be an integer. It's going to be easier if it's an int, I think. And why is this? Oh, okay, I see what's wrong. All right. So basically what was going on is we're going to go ahead and change this to be rotate with base, and we're going to pass in this base. So instead of using a hard-coded capital A and a hard-coded capital or lowercase a, we're going to pass in the base. Rotate with base, our base is going to be capital A, and then our delta. Then what we're going to do with our next part is we're going to say if R is greater than or equal to lowercase a, and R is less than or equal to lowercase z. Well, in this case, we know that we want to rotate with the lowercase a as our base. So we're going to return rotate with base R lowercase a delta. There's one final use case that you don't have to put in here. You could put a check somewhere else if you wanted, but in this case, we're just going to put it in here to make our code a little bit easier. It's going to be any other time that a letter doesn't fall in the capital A to Z or the lowercase a to Z, we don't rotate those at all. We don't cipher them at all. So we're going to return R. And we could actually change this function name to be Cipher. We pass in a rune and a delta, and that's what it's doing. It's doing our Cipher for us. And then this rotate with base, we can name it just rotate. We could get rid of this original rotate because we're not using that anymore. And then we'll have to rename these two. Then coming back up here, I'm going to delete all of this. I'm actually going to uncomment all of our original code, and then I'm going to delete the stuff that we don't need. So what I'm going to do is I'm going to say var ret, it's going to be a rune slice. I'm going to go through all of the characters in the input, and what I'm going to do is I'm going to say ret equals append ret cipher the character with the delta. And then at the very end, we're going to print out the string version of that rune slice. So I'm doing this because it's easier to work with a rune slice. Before we were using a string and we were converting a lot of things to strings as we went. This way we don't do that string conversion until the very end, so it should simplify things a bit. And you'll see here when we run this, it gives us the exact same output we were getting before. But our code, as you can see, doesn't have those for loops going through the arrays. It doesn't have the slices, and it doesn't have that sort of thing. but it still, still should work exactly the same. And we can even test this a little bit by tossing in things like smiley faces, saving and seeing what we get, and you'll see here we're still getting a smiley face out. So, we've got this, so it works pretty good. I think that's it for this exercise. I guess one thing we can do is copy this just to verify that I actually wrote it correctly. Let me go ahead and submit it and just see what we get. Hopefully I didn't make any mistakes. And it looks like this passes all the test cases as well. So which of these two solutions you use is kind of, I'll say it's up to you. There's a use case for both in my opinion. It's just, I think the first one is more practical as an exercise because you get to see, all right, how do I work with slices? How do I find certain characters in strings? And, how do I rotate through that slice if I need to get back to the beginning? Whereas this second, the second version of the exercise, it's arguably shorter. I think it is shorter. And it's going to be faster, but the problem is it's very specific knowledge. It's, you're learning very specific things about how characters are stored, which is useful information, but maybe not what you wanted to be learning right now.